Hi, this is Jeff Spence, your Math 120 instructor for the Community College of Denver. This is my video over the Week 8 discussion set answers. So let's get right to it. So we're using this histogram to answer the following questions. So it looks like here we're seeing scores on a test and the frequency of students. So if you look at this, I can see like one student scored in the 20s, two students scored in the 30s, one student in the 40s, two students in the 50s, and so on. So it says how many people scored in the 60s. Well, we look at the 60s, that's going to be right here. There'd be 6 people scored in the 60s. 6. How many people scored at least 80? Well, what does at least 80 mean? At least 80 means 80 and up. You know, sometimes they say you got to be at least 21 to drive, or sorry, at least 16 to drive, or at least 21 to buy alcohol or something like that. So at least means that number and up. So how many people scored at least 80? Well, it was all 13 in here, and the scores in the 90s. So 13 plus 5 should be 18 students scored at least 80. It says, what percent of people scored in the 90s? Well, to get a percent, I need a total. And my total is 39. When I do 1 plus 2 plus 1 plus 2 plus 6 plus 9 plus 13 plus 5, I get a total of 39. So I'm going to use that total. It says what percent of people scored in the 90s? Well, 5 people scored in the 90s, 5 people. So 5 divided by 39, and convert that to a percent, it should be 12.8%. I'm just going to round that to the nearest tenth. And what percent of people scored in the 20s? Well, only one person scored in the 20s, so 1 divided by 39, convert that to a percent, 2.6%. Alright, listed below, so that's the end of number 1. Listed below are the speeds from 30 random speeding tickets in Denver over the last week. Create a frequency, relative frequency distribution. Create intervals of equal width that do not overlap. So I can't list each speed because there's a wide range of speeds here. So what we have to do is create bins or classes or intervals of speeds, and then we kind of list the frequency inside each interval. I decided to go by widths of 20 here. Okay, I know it's 20 to 39 is only 19, but when you look at that, if you look at the difference between the lower bounds of each one, it's always 20, a gap of 20. So I decided to do 20. You could do larger, you could do widths of 10 or 25 or 20. I just decided to do 20 because I thought that was a nice breakdown of this data. Answers will vary here. This is not the only answer. Let me be clear. This is definitely not the only answer. Okay, so once you get up your intervals, as long as they are equal width and do not overlap, then you start counting out the frequencies. So, for instance, 20 to 39, I would need to count how many. Frequency just means a count of how many. So how many speeds are between 20 and 39? So if I scan through this, there's 1, 2, 3, 4. There are 4. Okay, same thing for 40 to 59. So 40 to 59. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright, I'm going to pause the video and continue to do this. Okay, so I have all my frequencies up, and just to double check that I make sure I did this right, there should be 30 total speeds. And 14 plus 4 is 18, plus 2 is 20, plus 5 is 25, plus 3 plus 2, 30 total speeds. So that looks good. Okay. Now, relative frequency. Relative frequency, another word for that is just proportion or percent. Okay, so I'm actually going to convert all these into percent. Technically, relative frequency should be the proportion, the decimal number, but I'm just going to make it easier to read. So how do we do this? Well, there are a total of 30 speeds. So the relative frequency for this interval would be 4 divided by 30. 4 divided by 30 as a percentage would be 13.3%. So each one, I just take the number, the frequency, and divide by the total and convert that into a percent. So I'll do that and pause it here. Okay, so now I have all my relative frequencies typed in. And remember, when you have these percents, they should add to 100%. When you add these up, I believe I might be off. It might just be off slightly from rounding. So if I do 13.3 plus 46.7 plus 6.7 plus 16.7 plus 10 plus 6.7, I get 100.1%. But that's just because all these 0.7s rounded up. Not a big deal. It's pretty damn close to 100%. So we're good to go. So just remember, when you have your frequencies, they better add up to 30. The relative frequencies better be all divided by the total and add up to close to 100%. And the intervals that you choose don't have to be 20s here, but they have to be equal width and they do not overlap. So that's how you create a relative frequency distribution. So it lets me know the breakdown of where the speeds are. All right, next, number 3. It says use the following data set to answer each part. So we have this data set. It says give the mean, median, and mode. Well, I've already shown the work for the mean just to save time. The mean, we add up all the numbers. So I've added them all up, and then we divide by the number of data values, which is there are 12 numbers up here. So the sum, when you add them all up, should get 84. 84 divided by 12 is 7. So 7 is the mean. To do the median, you got to put all the numbers in order. And the median is the middle data value. Okay, and we actually have an even number of data values. So when I cross off and get to the middle, I'm going to end up with the 2 5s, I believe, in the middle. If I double check that, yeah. So the way I get to the middle is I just cross the smallest off and then the largest, and then the next smallest and the next largest, and the next smallest and the next largest, and the next smallest and the next largest, next smallest, next largest, and I end up with 2 5s in the middle. Whenever you have two numbers in the middle, you just take the sum of those two and divide by 2. So 5 plus 5 divided by 2 is still 5. So the median is still 5. The mode is the value that occurs the most. If you don't have any values repeating, then you don't have a mode, but 2 shows up 3 times. And there are a couple other values like 3, 5, 8, and 6 all show up twice, but 2 shows up 3 times, so 2 is the most frequent repeating data value. The mode is 2. The range is easy. It's always the max minus the min, so the maximum value is 34. Subtract the min, that's 2, 32. And then the standard deviation, this is going to take some work. So I start off with a table so that I can get eventually I want to get the sum of the squared deviations, okay? The sum of the squared deviations. And that will give me, once I take that, I divide by the data values minus 1, and then take the square root of that. You've probably seen that formula in your homework. So the first, we got to get the mean, which we already have, is 7. So each deviation is the data value minus the mean. So for 2, I'm going to say 2 minus 7. I'm going to get a deviation of negative 5. All right, so let me finish out the deviations here. Okay, so I've taken each data value and subtracted the mean, and that's what the deviations are. So you see that some of the deviations are negative, some of the deviations are positive. They will ultimately cancel each other out. Hold on a second. Let me check something. Okay, so the deviations will cancel each other out. But remember, here's one thing I'm kind of shortcutting because I don't have a ton of space. There were 3 2's, so I really have 3 deviations of negative 5. I have 2 deviations of negative 4, and I have 2 of negative 2, and so on. I'm not showing all those, but I'll just do it at the end here. So what we need to do, since the negatives cancel out the positives, is to square the deviations. So negative 5 squared, 25. But how many values do I have? How many 2's do I have? I have 3. So I'm going to multiply that by 3 and get 75. All right, so remember, you square the deviations, and that's negative 5 squared is 25. But since I have 3 2's, I have 75 worth of squared deviations. Next, negative 4 squared is 16. How many values do I have there? 2, so that's 32. Alright, I have, so this squared deviation, negative 2 squared is 4. How many 5's do I have? 2. So 4 times 2 is 8. And then the next one, negative 1 squared is 1. How many 6's do I have? 2. So 1 times 2 is 2. And then 1 squared is still 1. How many 8's do I have? 2. So I have 2 there. And then 27 squared is 729, and I only have 134, so I'm going to have 729. All right, now I have to get the sum of those squared deviations. So the sum is equal to 75 plus 32 plus 8 plus 2 plus 2 plus 729, 848. Alright, then the next step is to take that sum and divide it by n minus 1, the number of data values minus 1. Well, how many data values do we have? 12. So I divide this by 11. Well, I divide it by 12 minus 1, which is 848 divided by 11. Divided by 11. Alright, so 848 divided by 11. 848 divided by 11. 77.09. Then the last step is to take the square root of that value, 77.09, and that will give you square root 77.09, 8.78. 8.78 is the final answer. That is the square, so that's the standard deviation. Okay. So remember those steps. You take each data value, you subtract the mean, then you square them. Remember, if you have multiple data values, you better multiply that value here, get the sum, divide by the number of data values minus 1, then take the square root to get your answer. Alright, I'm going to move this into two parts, so I'll be right back.